So today onwards we will start our allied calculation. Okay. So before starting, I will share you this PDF also. So here uh, they have given just how to do in case if you have you're not following how to do the calculations, you can go through this particular like PDF PPT. Everything is given here very clearly, so you can go like that also. So first what we will see first the allied software, and we will try to understand. See, we have seen the manual calculation in yesterday's class. Okay. And we have seen certain things like how to do the manual calculation and all, like how to get the minimum residual pressure and everything. But today we will see in the allied software. So I've just picked this one project just for today. We will see the already calculated project. Then in our next class we will try to solve one project because it will take much time. So as I already told you, we have to make one what you can say sheet first. Whenever you are starting the allied software calculation, the very first work what we have to do is we have to make this sheet. Before making this sheet, first we should do the sprinkler spacing. So that drafting work will be after doing the drafting work only, we have to enter into the allied software. Because if you have not done the any placement work, now as a design engineer you don't have to go to the system and do the work. You can place the sprinklers, if you are very good at drawing and all, just place in one sheet. Also you can connect with the node system, everything. Or it's better to connect in the AutoCAD also, because in AutoCAD you will get the accurate length, because the most important thing is the length. We require the accurate length and all. So for that I've just chosen one project here just to show you. First I will just show you how to do the allied calculation, how we should write down the notes, everything. Okay, based on that, let us see. So this is one project. Okay, this is the real-time project what we have done, one hotel project. So in this project, actually there are 5 floors. It's a G+5, actually G+5 hotel it is. But we have been done, we have not done anything on the ground floor actually. So we have started working from the second floor, because the second floor was the main maintenance room. Like if I show you this second floor, so the main floor was in the second floor actually. So this was some extension project, so where we have done some allied calculation also. So just I will explain you. This particular project is nothing but it is a hotel, 5-star hotel, and here you can see some rooms are placed here actually, like QA, KB, something like this. The names are written here, like king size, queen size, something like that. Rooms were there. And here some elevator lobby is there. It's a very simple project. Store room, mechanical room, and some IC room and staircases. So many things are given here, etc., etc. And here some QC room, staircase to corridor. So what we our task is to go for the sidewall sprinkler for the rooms, and normal pendant sprinkler for the corridor area. So this was the task given to us by the client. So that's why what we have done, wherever we have the rooms, we have placed the sidewall sprinkler. Now whenever we are doing any sprinkler calculation, like in the last class also I told you, it doesn't matter how you are placing the sprinkler, where you are keeping the sprinkler, but what it matters is the network of pipe. Okay, so network of pipe is the most important thing which we have to always focus on. Like in this example also you see, we have created one network of pipe. If you see, this is our shaft, for example, and here you can see there are 3 pipes are coming, one for the hydrant, one for the sprinkler, and one for the drain. So this particular pipe, green color pipe, is for the sprinkler system. And here you can see I have just highlighted with yellow color. So why I have highlighted with yellow color means just to show that this is my header pipe. So this is my header pipe. And if I start following from this particular point, you can see that my header pipe is running straight into the corridor, and it is going exactly till the last place wherever I want to keep the sprinklers. So here you can see all the pipe sections or all the sprinklers are connected with this network of pipe only. So I have focused on the network of pipe. Always you have to focus on the network of pipe because all the sprinklers are connected with the network of pipe. This is the definition of sprinkler and the firefighting system. Okay. So, and here I have highlighted one like rectangle box. So what is the meaning of this rectangle box means this is my last sprinkler position. Okay. Suppose just imagine if this is my what you can say shaft area. Okay. If this is the shaft, so obviously if I follow this shaft and this routing, so this will be my last sprinklers. Okay. Like either this number 10 or number 40 or number 60. Any of these three sprinkler can be last. I don't know which is the like most demanding or what you can say further sprinkler. But if I include all this sprinkler in my calculation, so there may be chances that the software can calculate. Okay, the software can calculate this particular what you can say which is the farthest sprinkler, because software will calculate based on the pressure, based on the velocity, and based on the flow. We just by thinking I can assume that 10 is the farthest sprinkler, or 10 is the sprinkler which is having the minimum residual pressure 7 psi. But once the calculations are done, you will understand which one is the highest. Okay, which one is the farthest. Now first what we will do, first we will try to understand this node diagram, because whenever we have to start any firefighting project, place the sprinkler, connect with the network of pipe. Suppose this work you have done here. For example, you have placed the sprinklers and you have created the network of pipe. After that, what you have to do, I will just write down the steps here so that it will be easy for you to understand. Whenever we are starting the allied calculation, so what are the things we have to do? First, we have to do the sprinkler, like we can write down the sprinkler calculation. Okay. First, we have to do the sprinkler calculation, because without sprinkler calculation, without the knowledge of number of sprinkler in the project, we can never do the allied calculation. Second thing, what we will do once we have done the calculation, we have to do placement and networking. Okay, I will write this placement and networking, or you have to connect with the network of pipe. Okay, so this is one thing which has to be done in AutoCAD. Okay, this particular thing has to be done in AutoCAD, placement and network of pipe. Okay, you have to just place however you want and connect with the network of pipe. Once you do these two things, the next thing what we have to do is we have to write down the nodes. Okay, or I can write down this term, nodes arrangement. This is my third point. What I can do, nodes arrangement means, for example, here you see I have written the nodes arrangement like 10, 20, 30, 40, 50. This is my arrangement of nodes. First, we have done the sprinkler calculation. How to do the sprinkler calculation? Again, it is very simple. Here, one sheet is given. Just follow this sheet, sprinkler selection sheet. One is the density area method. One is the hazard method divided by 225. One is the actual sprinkler. Whatever you want, you can just write down, select the number, and you can do this sprinkler calculation. Then placement and network of pipe. If you are not good at CAD, or if you don't want to waste your time in CAD, just draw some beautiful drawing. Okay, and you can do this placement and network of pipe first roughly, then you can go for the fair one also. That one also you can do, but it is suggestible that we should do in CAD because of the length. Okay, if we do in the CAD, we can get the proper length. Once this is done, go for the nodes arrangement. And after nodes arrangement, what we have to do means this table we have to create. Now see, this is my way of working. Okay, it is not necessary to create this table, but this is my way of working. So just what name we can give, you can give anything, table or node table, whatever you want, you can give this name. Now, why I'm making this table means, because it will be easier for me if I have the actual data written here already, then I can go to the software and I can just input the values. Okay. So that thing will be very much helpful for me. Okay. These things are done. Next, once I do these things, once I complete up to this point, then only I'm going to open my Allied software. This is the preliminary steps. Okay. Now, what I need to focus here means, now again, I will divide this particular portion into 2-3 things. Now this particular portion I will divide into 2-3 things. Like what are the things? First, what I will do, I will try to find where is my zone control wall. The first thing what I need to do is, in the table itself, I need to write down this zone control wall. Why means, because from the zone control wall, my riser pipe will like come out. So that's why I will write down in this particular Excel about the zone control wall. And second thing is, I will also write down wherever my hydrant is connecting. Sometimes what happens, the hydrant will be connected with our system, or we need to include the hydrant. So this is my second thing. And obviously, wherever you have the zone control wall, the hydrant will come there only. And third thing, I will also focus near the pump area. Like first, I need to select whether any internal hydrants are connected or not. And even if you are connecting the external hydrant, everything come in the loop network, because the meaning of node is that it is a closed loop. We are working on the closed node or closed loop. Our node system should not be open. Okay, if it is open means we cannot do the calculation. So remember that whenever we are working, we have to work on a closed loop or closed. The node system should be closed. So these are my 3 focus points. Zone control wall, whether how many number of hydrants I am connecting, 2 internal, 1 external, or 2 external, 2 internal, whatever the thing, you have to connect this with your node system. Suppose if I want to add 2 external hydrant means, my node, whatever the node which I am going to make, that particular what you can say external hydrant line should come in that node. That is the main thing. This thing we will see later. So suppose I have just made this sheet. Okay, first I will explain you how I have written this node. Okay, just I will go to the this thing. Suppose I have made this drawing and all. Everything I have checked according to NFP and whatever the like pipe, what you can say, whatever the like distance between 2 sprinkler, everything I have followed. And suppose this layout is approved by client. First you have to get the approval also, because without getting approval, if you do a light calculation, then your approval failed means your light calculation will also get failed. So to check for the approval from the client. Now you see, this is my zone control wall. This is my zone control wall, and my target is that I need to connect a network of pipe from this point, and I need to connect these 6 sprinklers. Suppose this is the area I have taken. So maybe I try to find 1500 square feet area. So I got this area, and in this area, how many sprinklers are there? 1, 2, 3, 4, 5, 6. There are 6 sprinklers I am connecting here. Okay. So this is my how I am going to do. You have to decide. Okay. The decision also you have to take, how many number of sprinklers you are going to select. Okay. How many number of hydrants you are going to select. It's up to you. So sometimes you can go with 6 or 7 sprinklers, 10 sprinkler. And if the building is very, very big, for example, if you are doing for high-rise building, you can go for 16 sprinklers also. And if you want to add more sprinklers, you can add more sprinklers. But remember that the number of sprinklers increasing, your calculation will also increase. Okay, the pressure will also increase. The flow will also increase. The lesser the sprinklers, the calculation will be it will take less time to calculate, and the flow, pressure, everything will be in a very suitable, what you can say, the values will be very much suitable for that. So like that, I have to decide how many sprinklers I am going to select. Suppose I have selected this sprinkler, and here just check this particular line. Yellow color line is my nothing but it is my network of pipe, uh, which is coming from this sprinkler, for example, and it is going to the zone control wall. And in the second floor, for example, we have the pump room in the second floor, because we were told that the pump room is somewhere here, but it was not shown because the pump room was not in our scope. So what we have done, just we have kept here the PG and FS is nothing but this is the pressure gauge, and we have just keep it like that only. This is my suppose target point. This is my starting point, and this is my ending point. So you have to make sure that everything is connected in a network, because if it is not connected in network, then what will happen? I can never justify my design. Okay. If anything is missing out, software will also not take. Okay. The values, whatever the things we are going to do, software also will tell that your network is incomplete. Please complete the network, and then please complete the node, and again recalculate the things. Now, how I am going to write? It's very simple. So wherever the sprinkler, now notation, you can do anything. You can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or you can write 5, 10, 15, 20, or you can write 2, 4, 6, 8, 10, 12, anything. So I prefer to go with this method, 10, 20, 30, 40, 50. So why I'm writing like this means, suppose in case I missed out anything in between. For example, if I missed out anything, suppose I missed out any one line here, so I can go for 15, 25 also. Like that also I can go for. So that's why I have taken this pattern. But still try to make this sheet accurately, because your allied calculation depend upon this sheet only. So let us try to understand this. First, I have written node number 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Just observe one thing. Every termination point I have taken as the node. Every termination point I have taken that particular point as node. For example, this is the starting point. This is the terminating point for this particular pipe. So I have written the node. This is the starting point, and here some T is going to come. So obviously this will be the terminating point for this particular pipe. So I have written one node. This is the starting point. I have written one node. This is the terminating point. I have written one node. Again, this is the starting point, and this is the point where some T is going to come. So I have written one node. In the same way here also, I have written one node, like the one which is, again, the pipe is connected here. So this is the starting point. This is the terminating point. Like that, I have written here 90, 100, 101, 110, 20, 130. And here also, this is my terminating point. One elbow is going to come. That's why I have written one elbow here. Okay. If you want to skip any note, nothing will happen. But you have to include this elbow in your calculation. Okay. If you don't include elbows, and if you are like forgetting 10 elbows, 20 elbows in your calculation, obviously the results will not be accurate. And you have to like again recheck it. And if someone is checking very closely, you will get caught, like why you have not added these things, etc., etc. So and if you're adding additional values, it is more than good. Suppose, for example, if you are having some 16 T's, the reducers or T's, you are adding 18 numbers, nothing will happen. Because if you are adding more, it is very good for calculation. But if you are adding less, means it is very, what you can say, the results will not be appropriate. 130, 140, 150. After 150, I have written 160 here, because the pipe size is changing here. From 2 it is 2.5, 2.5. Then the pipe size is changing to 3. So it's up to, like, I can write here also 160, 170, 180, 190, but my calculation will go very lengthy if I'm writing like this. So instead of this, what I have done, wherever like some point I have missed out, and I have written one. Now, obviously, I am going to include these fittings in my calculation. When I'm going to do the calculation for node number 150 to 160, I'm going to add. After 160, now the pipe size is changing. 3 inches is coming, and up to where this 3 inches is coming, I have taken that node. See here, I have taken 170. Next, the pipe size, wherever the pipe size is changing, up to that point, I have taken the node 170. It's up to you. Okay, this is your understanding. If you want to include, again, in between, if you want to take, you can take this. From 160, 170, the distance is.
Sir, hello.
Yeah.
Sir, just one question. So shall we need to consider the fitting as well, because definitely there will be friction losses in between the fitting.
Obviously, we have to consider the fittings. This everything will be considered as fitting only. See, this is fitting, this is fitting.
Yes, yes.
This, because T is coming here. So everywhere I have to consider the fitting, but I don't have to include this sprinklers, because sprinklers I am going to consider only 6 numbers. I don't have to consider those sprinklers. Only these sprinklers I am going to what you can say consider in my calculation. After 170, my pipe size is changing to 4 inches. Then it will go 4 inches wherever it is. Like, okay, after 170 directly I have taken 180 here. So what I have done here means wherever the pipe size is changing, simply I have taken that node. Why means because to avoid my calculation steps or to avoid the lengthy calculation procedure, I have just taken this thing. So there are 18 number of pipe sections are connected here. Then go to the second floor, again start from 190 and 200. 200 is my last, what you can say, this is my last node. So I am starting from 10 to 200. So there are 20 pipe section. And in the same manner, what I have done, like first I am writing about 10 to 20. So here what I have done means simply I have written first beginning node, end node, 10, 20. Second thing is pipe material. Pipe material is always constant, whatever the pipe you are selecting. Suppose if I am using MS pipe and GI pipe, so the code is 4. According to the Elite software, the code for that particular pipe material is number 4. So I have written number 4. If you want to select another pipe, you can select this. Now diameter, how to select diameter? Yesterday we have seen in the last class. If the 2 sprinklers are connected, we have to take 1 inches. If 3 sprinklers, 1 by 4 inches. Like that, you have to select the what you can say diameters. And whenever you are doing, always add all the sprinklers. Suppose if I want to select the pipe size for this particular pipe section, I have to add all these sprinklers. If I want to check the pipe size for this particular place, so I have to add all these sprinklers. Whatever the sprinklers, check in the table, write down the values. So if you count the sprinklers, obviously we'll get whatever the pipe size I have written here, 4 inches. So 4 inches is, I think it is for some 100 sprinklers. Let us see where it is given. Somewhere is given. See here, if you open this one, so here they have written this one, pipe sizing. See, up to 100 sprinkler, 3.5 inches, and maximum they have given only 4 inches. So, okay. So 4 inches is more than enough. What you can do, you can divide the section also. That also I will show you. Like sometimes you will divide into 2 or 3 sections and you can do the calculation. But everything should be collected in the network of pipe only. So I think pipe sizing should not be confusing for you. Just you have to follow this particular number of sprinklers and you can write down the pipe size. And the maximum pipe size in last class only we have seen that the maximum is 4 or 6 inches we have to take. So that is clearly mentioned. Now the most important thing here is the length. Okay, length is also not an important parameter. Just calculate the length. Okay, here I have just written the length also. So you can just follow this length also, whatever is written, like 5 feet, 5.5 feet, and whatever the feet are written, 8.5 feet. So lengths are also written like accurately. I have written the length, pipe, beginning node, K factor. Where you have to write K factor means wherever there is a sprinkler, there only you have to write the K factor. This is the most important because K factor is for sprinkler. Obviously K factors are for sprinkler. So we have to write K factor. Suppose if I am selecting 6 sprinkler means in my sheet there should be only 6 K factor, like 1, 2, 3, 4, 5 and 6. There are 6 K factors. Even in my calculation also, only 6 K factors should be available. Next thing is the sprinkler elevation. Now, what is the meaning of sprinkler elevation means? It is simply understand like this. Suppose for this example, this is my 1 minute. What happened to this? It is not working. Suppose, okay, just a minute. Why it is not coming? Sprinkler elevation is nothing but from your pump, okay, at what height, okay, from your pump at what height the sprinklers are placed. For example, if your pump is at some place, I will just open, just a minute.
Boss, I do believe the sprinkler height, it is within the room, within the same room.
Yes,
I will,
definitely. I'm also talking.
sprinkler elevation is
Sir,
something different. 1 minute. Yes. See, sprinkler elevation means the height of the sprinkler from the pump, from the fire pump. You have,
How?
yeah. Where is your fire pump located? In basement or ground floor? So at what height the last sprinkler is placed? Actually, this is not opening. Otherwise, I would have shown you. 1 minute. There is one option for whiteboard here also. Let me check that. Where is the whiteboard? Whiteboard. Sorry. Just a minute. I need to, because if I can write, I can show you. This is not opening actually. Internet problem is there. So anyhow, I will just, for example, if you are now see here, I have written the elevation feet here. Suppose if you have 4 floors, okay, 4-floor building, each floor is having 10 feet, for example. So 10 feet means it will be like 10 feet you have to add. And whenever you are coming to the fire pump, you have to add some more height for the fire pump also. So that is written here. Otherwise, wait a minute. I will write down here and explain you. See, suppose this is my this is my building, for example. Okay, sorry, I have to write. See, suppose this is my building, okay, and this is 2nd floor, this is 3rd floor, for example, this is 4th floor, and this is for example 5th floor. As per our example, I am telling you, here some sprinklers are placed. For example, at this point, sprinklers are placed actually. So these are the sprinkler, whatever the sprinklers. So these are placed here. And suppose, for example, my fire pump is somewhere here. For example, this is the 2nd floor. Somewhere here we have the fire pump. Now, this height, this is how it is connected to the sprinklers. For example, just I am showing you the example. Now, these are the sprinklers connected to the fire pump, for example. Now, what we need to do means we have to calculate the height from this place up to this sprinkler. Okay. So what is the, at what height the sprinklers are placed from the fire pump? Now you got my point. Suppose this is 10 feet, this is 10 feet, this is 10 feet. Okay, all the heights are like whatever the height, from 5th floor to 4th floor, 4th floor to 3rd floor, 3rd floor to 2nd floor. Then you have to come down up to fire pump. So what height at what height the sprinklers are placed. So here you can see all the sprinklers are placed at one height only, because we are doing this in our what you can say, in our 5th floor only. So all the sprinklers are placed in one height. So in our example, this example I have taken 40.6 feet. Why means because this is 2nd floor, this is 3rd floor, this is 4th floor, this is 5th floor. The height between 2nd to 3rd floor is something, I think so, 12 feet. This is also 12 feet. This is also 12 feet. So totally how much it will? 36 feet. That means what I'm trying to say, that this height,
36 feet.
yeah, 36 feet from here to here. If I am calculating the height from this point to this point, it is 36 feet. So what I have done means I have added this 36 feet plus extra I have added. Okay. Like if you know the accurate heights, then you don't need to add extra. But here what I have done, just for safer side, I have taken some extra because whenever you are talking about the pumps, so obviously if this is my what you can say, if this is my base of the pump, so pump center will be somewhat 2 to 3 feet, it will be higher, on the higher side only. So you can little bit reduce also, but here I have written 40.6 actually. And this is the height. I think this is not the height. 1 minute, height is measured somewhere, because something we have written height. Just understand this thing clearly. Whatever the height of the sprinkler from the fire, that height you have to write down. Okay. If you understand this, it will be very much just okay. Just understand this thing, because this is the most important thing. If you don't write this sprinkler elevation, and you can observe here in my example, the sprinkler elevations are almost same up to zone control wall. Why? Because means up to zone control wall or up to node number 180, the sprinklers are running, or the pipe is running in the 5th floor only. Then suddenly I have come to the 2nd floor. So here what I have done means, here I have written 4 feet. Okay. Now you have two options. You can come floor by floor also, like after 40.6, you can minus 12 feet. For example, minus 12 feet, 28.6 minus 12 feet, 16.6 minus 12 feet, 4.6. Like that also you can do. But just to, for example purpose, I have written this one. Okay.
Why suddenly we moved from 40.6 to 40?
Yeah. You can
Okay.
three more. You can add 3 more notes also. But just
Boss, it should be the same, right?
Sorry?
At node 180, node 180, 190. Why it is not the same 40.6 and 40?
Because this is in the 5th floor. This is in the 2nd floor. Node 180 is in the 5th floor. Node 190 is in the 2nd floor. So I have just reduced the distance or the length. Or you can say height also. Because
No, boss. How it is in the 190 is in the 2nd floor?
here I have shown no already here. 190 is the node number 190 is written in the 2nd floor. Coming in the shaft, from the shaft dropping. This particular is dropping from the shaft. So once it is dropping at this floor, it is 190. Our fire pump is in the 2nd floor, for example. So that's why we have closed here only. Okay. Wherever you have the fire flow, wherever you have the fire pump, you have to take up to that point. So in this example, we have the fire pump particular.
Still, I didn't get the 40, the number 40. How would you calculate it? It is the distance from the 2nd floor at the pump.
Sorry, 4 feet.
40.
See, 4 feet is. That's why I just need this one. Otherwise, it's very difficult for me to explain. This is not working actually. So I need some code to write down actually. Otherwise, just understand this thing, that from the top floor, whatever the last floor, up to the what you can say fire pump, you have to calculate the height actually, length, and whatever the length you are getting, that is your sprinkler elevation. the elevation of the sprinkler. So in this case,
Very good point.
it is 40.6 feet.
Very good. At the number 40 at node 190, how it became from 40.6 to 40?
So it
Why
is
it is
coming to
close?
the second floor. I cannot write 0 here. If I write 0 here, how can I do calculation? So I have written one random value, 4 feet. Okay. So here I cannot write 0. Actually, if I write 0 sprinkler elevation means my calculation will never go. So just
But at node 190, at the discharge line, really the elevation is 0, right? This 190 at the discharge line, right?
because there is no elevation near the fire pump,
That's what I'm telling you. Why you put it 4? It should be 0. 4.
we cannot write the 0. How can you multiply 1 lakh with 0? Tell me. If I multiply 1 lakh with 0, the value will be 0 only. So that's why I have written this one random value 4, because in our calculations there is no 0 actually.
It's also we have to install we will not install the pump on the ground. There will
Yes,
be
yes.
some foundation.
The mounting foundation will be there.
So it's a 300 mm minimum, 1 foot.
1 foot, or you can
Minimum,
1 foot.
as per standard. So
Yes.
you can increase this, and when you see the discharge of the pump, it will definitely go upward. There are some fitting valves, so that normally we take it 2 feet, 3 feet like this.
2 feet, 3 feet will come actually, yeah. And this line 190 to 120 is exactly coming in our like it will come exactly in this position, like wherever we have the pump. So obviously this will be like from calculation point of view. See, this value has nothing to do with our calculation, because nothing will happen if you take some 1 feet, 2 feet, 3 feet. But yes, if the sprinkler elevations you are taking inaccurate values, obviously the flow and pressure will be less, because the more the height, okay, the more the height, the more what you can say, the accurate calculations will get. And the elevation is nothing but just the height for the sprinkler, whatever the things you are doing. So based on that, I have written one more example here. So I think with this example, you will understand it very properly. I think, see here, just a minute. See here, I have just reduced the sprinkler elevation. So this is how you have to reduce the sprinkler elevation. Like see, after 121, see gradually it will decrease. 107, 93, 81, 68. Finally, it will come to the 0 elevation. But we are not taking 0 elevation as 0 feet. Any value we are taking 3 feet, 4 feet, 5 feet. This example just I have I have not added. I have gradually taken 40.6 to 4 just to avoid the steps. We have done this thing. So I hope you understood this. Now here you see this is a sprinkler elevation. What is the meaning of non-sprinkler flow? Means wherever the hydrant is coming, you have to add the flow. Like in our example, I have added the, in this point only I have added, because here I am expecting that this line is going to cross my sprinkler, or if it is not crossing also, no issues. I have to add hydrant somewhere. So I have added here, because if I don't add this hydrant GPM value, so hydrant calculation will not come. So I have added here 180 to 190, because like this, in this example, what we have like what the client was suggesting, that you have to cross this line. Okay, whatever the line is crossing, it should go from the sprinkler actually. So since we have two, if you remember that I have shown you this particular thing. So if you understand this, I think we have seen this one schematic drawing. So based on that schematic drawing only, we have to do the all the what you can say combined system. Where is that? See this one. So in this particular, what happens in this? Yeah, in this particular, what happens when you come to the zone control valve? So in the zone control valve, your hydrant line will cross the sprinkler line. So this is the concept we have utilized here. Same thing, whether the hydrant line is crossing sprinkler line or sprinkler line is crossing hydrant line, that is a secondary question. So that's why I have written the hydrant value as 100 here. And why we have written 100 here means clearly in the NFPA 13 it is mentioned. If you open NFPA 13 and go to the page number something, wherever we have the calculations, here I think they have given one table for hose. Just a minute. Somewhere they have given 0, 50, 100. Okay. If I'm not getting here, you will get. See, somewhere we will get sprinkler coverage. Okay, not this one. Sprinkler types, pipe schedule, hydraulic design is not given. NFPA 13 versus NFPA 14. See here, this is the hose stream demand and water supply. You will get in this NFPA 13. So here clearly they have written that whenever you are selecting any inside hose GPM, either go with 0 means you are not selecting any hydrant system. 50 means you are going with one hydrant. 100 means you are going with two hydrant. And NFPA 13, NFPA 14 has clearly mentioned that whenever you are designing the firefighting system, you have to go with two hydrant system inside. So based on that, what we have done, we have taken 100. Suppose if I want to take inside and outside, so what I have to do means I have to take 100 for inside, 100 for outside, 100. Okay, so outside hydrant will obviously come near the pump. Okay, and suppose if I'm doing for the ordinary hazard also, I have to write 100 to 50. For extra hazard, 100, 500. Like that, it is written here. So that's why I have mentioned here, near the zone control wall only, I have taken what you can say, this non-sprinkler flow value. Okay. How to understand that this is the zone control wall? Because of this fitting, ETBC, elbow T, butterfly wall, check wall. This is the zone control wall. So if you written anything fitting like this, first fitting, you will understand that this is the zone control wall. Then finally, you have to write one more fitting, which is the pump. Near the pump also, we use some, what you can say, valve packages. So that is also, like I have written here, ETBC, you can write G also for gate valve. Like that it is written. And this is the most important fitting column. Why means because here you see some complications you will find. If you go near to this, like 140, 150, 160, 170, there are a lot of fittings adding here. So first let me start with the node number 1. Now here you see, whenever we are talking about the sprinkler, so you have to add one elbow here. Whenever, because sprinklers are not directly placed, one elbow will be, no, obviously one elbow will be installed first. Then only we have to, what you can say, we have to put one elbow, then the sprinkler will be coming from that elbow. So the very basic rule is whenever there is a sprinkler, you have to go with the elbow. So that's why wherever you will see that, wherever I have written the sprinklers, I will write elbow. Okay, here elbow, this is elbow.
Elbow, boss, Mr. Atif, elbow for the drop of the pipe to the sprinkler.
Yes,
right?
yes, for the drop of.
Okay, that means this is the drop is maximum 30 centi, I do believe.
Yeah, yeah. So you have to write the elbows wherever there is a sprinkler. Next you see from 10 to 20. Now from 20 to 30 also I have written one elbow here. Let me just close this. It's a little bit confused. In the 20 to 30 also I have written one elbow. Why means because you see to connect 10 to 20, to connect node number 10 to 20, we require one elbow here also. So that's why I have written one elbow here also. Then in the same way, now you see the writing of the node, you can write anyway. It is not necessary that you have to write in a order. Okay. But whatever you are writing, just close the node number. Like see, first I have written 10 to 20, 20 to 30. Directly I have written 60 to 50. 10 to 20, 20 to 30. Then I have written 60 to 50, 40 to 50, 50 to 30, 40 to 50, 30 to 50. So like that, you have to always close it. And just follow one trick. Wherever you have the sprinkler, try to start your node number from that particular point. It will give you some good results actually, if you write like this. So 10 to 20, 20 to 30. Now in the 60 to 50 also, I have taken one elbow, okay, because one sprinkler is coming. 40 to 50. 40 to 50,
Boss,
one sprinkler is coming.
at node, Mr. Atif, at node 20, there is elbow also as well. Why you didn't put elbow E? At node 20.
This is the
At node,
code. This is the code given in Allied software. E, T, B, C, G, like that the code.
no, you didn't get my point. At node 10, you put elbow because of the drop of the sprinkler later.
Yeah,
At node 20, also there is elbow, but you didn't write E. Why?
I have written
At node,
node number 20 here. T. E is written. No. Node number 20 also I have written E. Why means because
no.
here terminating. No, this particular pipe is terminating. The pipe is coming here and then it is attaching with this particular pipe. So that's why I have written one elbow here also. This particular. Now, if I'm writing for 60 to 50, see 60 to 50 also I have written one elbow. Why means because actually here 60 to 50 is coming like this, 40 to 50 is coming like this, then 52 it is going to the 30. So at this point, what fitting you are going to take, that also you have to decide. You can take T also here. This point
This is T.
T, yeah, because this is 1 inch, this is 1 inch, this is also 1 inch, because only two sprinklers are connected. Either you can go for equal T or
Equal T.
yeah, equal T, you can go for equal T. So I will just change this fitting 40 to 50. Yeah, this one should be T actually. Next 30 to 50. So again, you see in the 30 to 50. Now understand this, whenever you're talking about 30 to 50, don't include this upper one. Try to include this one, this section. So actually here also I have written T. That's why I have written here elbow actually. 30 to 50, I have written T here. I have taken actually two fittings should come here. Now you see the confusion will always come. Okay, whenever you have to decide what fitting should I take. See here, obviously this kind of confusion you will get when you are doing very when you are doing for very complex projects or complicated project. So you have to decide which fitting I have to take, whether should I go for T or I should go for E, or I should go for both T or elbow. So that confusion you have to be ready for that situation, because obviously it will come whenever you are doing the hydraulic calculation. The fittings are very complicated actually. Writing the fitting is very complicated. So here also I have written one T here. Next we will go to the 30 to 80. See, after 30 to 50, 30 to 80 also I have written one T. Why means because the size is changing. Here 1 inch is coming, here 1/4 inch is coming, here 1 inches is going. So I have included this 30 fitting T. Okay, next we will go for 70 to 80. In 70 to 80, normally elbow is there. Then 80 to 100. 80 to 100, again one T is coming here, because size is changing, 1 inches, 1/4, 1.5 inches. Then go 100 to, after 80 to 100, 90 to 100. Again sprinkler is coming, elbow, 100 to 120. 100 to 120. Again I have written one T here, because the pipe size is changing, because one sprinkler is connected here and one pipe is coming from here. So obviously the pipe size is changing. 110 to 120, same thing. Okay. So I think in every node you will get one fitting. Either you will get T or you will get E. So this is 100% sure, because mostly very few fittings, very few places you will not get fitting, but every places you will get one fitting. T definitely will get T. Number of T's will be more in our projects. Okay. Like that.
Mr. Atif, from node, let's go back from node 10 to node 20. There is elbow at the corner, and there is one more elbow at the sprinkler itself. Why you are writing only one elbow? It should be two elbows.
110 to 120.
No, 10 to 20. Not 10 to 20. The first one. Last.
Only one elbow is there, 10 to 20.
No, there is one more elbow at the sprinkler itself. When you connect the sprinkler, you have to make elbow.
So I have written here in the node number 30. I have written.
Yeah, you consider the elbow at the 20, but there is another elbow at the 10. Before you fix the sprinkler.
Already written.
Sir, no, he's asking for the upright. If you make it upward or downward, so you will add one elbow here with the sprinkler.
At the sprinkler itself, other than the corner.
Under the sprinkler or above the sprinkler, there is an elbow.
There is elbow. Why are you writing only one elbow? It should be two elbows between 10 and 20. You got my point?
Yeah, I got your point. So, but initially you don't know which type of sprinkler you are going to add, or if you start adding much fittings, so the the design review team will ask us why you are adding this much of fittings. It is not required. So like so many questions will come. So it's better that if you are getting this kind of confusions, it's better to add some extra elbows or T's in your project. Same. I will be writing so many elbows, so many T's. So at some place I can cover it up. But if I'm start writing two elbows in the sprinkler only, so this is a highlighting point actually. I'm writing two elbows here. Obviously the one who is reviewing, he will catch that point and they will try to ask us why you are adding these two elbows. So that is the reason. So initially we should not add those things because the site condition will be obviously different if I am doing this one. So if you see that throughout the project, I may miss out any one fitting. Okay, it is possible that even if you are doing any calculations, like if you are adding fittings, there may be possibility, there may be 100% chances that you may miss out any one fitting. How to compensate that? Try to add some fittings, but I think 10% is more than enough. If you are adding extra 10%, for example, if there are 30 number of fittings and in your calculation you are considering 33 or 35 fittings, nothing will happen. 10% is a very very minimum value, because this is a very simple layout. You will get complex layout, complicated layout. In complicated layout, we have to consider a lot of things actually. So it's up to the designer how they are adding the fittings, because sometimes what happens, the fittings may missed out. Okay. If you see this particular 140 to 150 here, I have written 2T. Why I have written 2T? Because see, from 140 to 150, two lines are going. This is one branch line and one branch line. So I have added these two T's, but I have not added elbow here. Okay. So I may missed out. Sometimes I can do, no, I have added elbow, sorry. So elbow and fitting I have added here. One elbow, one T.
You're right, 2T, you're right, 2T.
Yeah. But if you check from 150 to 160, 1T, 2T, 3T, 4T. I have written 4 T's here. Now complications will go on when I am going for a longest. Suppose I have made this one as the longest. From 160, I am writing 170 somewhere here. So I have to, there may be chances that I may missed out 1 or 2 T. So in this kind of places, you can add extra T's also. So your all the previous ones will be compensated if you're writing like this. Like here you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Elbows.
Not elbow, T's are coming. Here okay. Will not come because we are going in a straight line. Here also you see, if I start writing from here, 170, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, this is 20, 21, 22, some 22 are coming, but I have written here 24. So I have just written some extra values because sometimes it will like you can compensate it. Say if you're not writing one or two fitting also, nothing will happen, because anyhow after doing the calculation you are going to take factor of safety also 10%, so everything will count in that. Finally at 180 190 I will write ETBC, just ETBC, one elbow, one T, one butterfly wall, one check wall, and here I will add non-sprinkler flow. And last 190 200 I have taken extra elbow here. So if I have missed out any one elbow, so I have just compensated here. Here I have taken two elbows, the one which is going down here, like terminating wherever it is. So like that you can compensate in these regions also, you can compensate any elbows or T's if you have missed out anything. If you feel that you have missed out some T's or elbows, you can write, and we don't need to write the reducers, only we have to write T's and elbows. Okay. So I hope you understood this sheet, how to make.
Mr. Atif, why we cannot add the reducers? It's a type of fitting as well.
T and reducer only. The meaning of T is also same, reducer is also same. Because it is also reducing the size, T is also reducing the size. Reducer is used for two-way fitting. It is used as a two-way fitting. T is used as a three-way fitting. And in our projects, in our firefighting, you can clearly see that we have three ways. Okay. See, I have avoided four ways. If I have like kept this pipe here, it will be four-way. But I have avoided this situation because it will create confusion for the purpose of elite calculation. So you can see here, one pipe is coming from here, one pipe is coming from here, one pipe is coming from here. So instead of reducer, I will write down the T here. Okay. This is the file. If you want to make perfect file, follow this particular also.
Sir?
So, yeah. This one also you can follow this, like it at each every point you can write the elevation, what is the elevation, height and all you can write down. So these kind of files will give you some, like say 100% you cannot create accurate file, but at least you can be near to 100%, 90 to 95% you can create, because anything we can do some mistakes, that's an like that is usual. So how we are compensating our mistake? By taking some factor of safety, 10%, 15%. So whatever the things you have done, it will be what you can say closed up. Yeah, you are asking something.
Can you go back to the CAD file?
CAD file.
So instead of having this type of connections in between 150 and 160 node, you can
write down. See, I can also write down from here also. After 160, I can write this 170, 180, 190.
No. What I'm talking, what I'm trying to talk to ask you, can we connect this like this in single instead of having number of connection in header?
No. We cannot do that, because if you do like that means again the project, you don't know what will be the result. And why we are adding this means because the pipe size is changing. So that's why I have written here, because wherever I have written the note, the pipe size is changing. That's why I have written this notes. So if I take from 140, suppose if I write this 140 and skipping this 150, 160, directly I am writing here 150 means it will not justify, because we have to write the pipe size also. We have one section where we have to write the pipe size also in our Elite software. What pipe size you are going to write? Suppose if I am taking 140 here and 150 here, what is the pipe size I am going to write? Because there are 3-4 pipe sizes are coming.
No,
so,
sir,
yeah.
Can you just zoom? Yes, that point. You have mentioned here T reducer, and then next to the that sprinklers, and it will connect it to the again header. So there will be lots of fitting. So you have you have mentioned on the CAD, but it is not possible to install like this way.
No.
Because itself fitting has itself length 170 mm, 150 mm. So how can you install here fittings, reducer, T?
You are talking like how to install this fitting.
No.
Yeah.
There will be some space required to install the fittings like
See, this
T
is,
and
see,
reducer.
in the designing stage, you don't have to think about the installation. You will give this drawing to the, like, if the drawing is approved, you will give to the
Then
spec. They will do
it
some
will challenge
adjustments. Yeah.
then sir, it will challenge to us in coordination perspective. So that's why.
See, whenever we are doing the shop drawing, we have to once again do the calculation, because if the contractor is changing, suppose if the contractor is changing the layout, then you have to obviously do the calculation once again, because what will happen means this calculation you will be doing according to your drawing, but the site condition is something different. So that is the different thing. And don't bother about the pipes are very close to it, so that installation team will take care of actually. When on the site
Okay.
condition they will, yeah, we don't need to bother about this thing, like why we have kept the sprinklers here. See, this sprinkler is crossing, like it is going from the wall. Sometimes what happens at this position, you cannot like you cannot go through the wall. So what contractor will do, they will take some alternate means and they will ask the designer to update it. So we will do the shop drawing according to that. So that is the different scenario actually. Suppose if you have created this sheet almost accurate, so what you have to do, once you have done this sheet, then only we have to open the Allied software. Now let us open the Allied software, and first let us try to understand what is the Allied software. Okay, what does it means?
Did you send us the software, Mr. Atif?
I will share it today. Whenever you are opening, if you have the files, you can open, otherwise you can go with the new file. Suppose if I am going with the new file, so the first thing what we will get is the like non-technical data, project
detail.
designed by date, code reference, client data, company data, building data, not required. System data is the most important, because here you are going to define what is the system you are going to consider in your calculation. And here you don't need to bother about, just if you click here, like if you keep or click here, software will automatically explain you what is this point means. Like for example, this particular point is used for the in-rack sprinkler. If you have the in-rack sprinklers, like in-rack sprinklers will come in the storage type of building. So this input, okay, for the in-rack sprinkler where required, if you must consider in-rack, be sure to enter the flow both here and at the non-sprinkler node. This is given. Now inside hose, if you click in the inside hose, it will tell you automatically what value you have to take, 50 GPM or 100 GPM. So the software itself is guiding us what value we have to take, 50 GPM or 100 GPM.
Sir, one more question. Can't we change the units?
You
Because
can
it's
just
again.
see, you can click here, you can change the units. Just click on this particular, and whatever the unit you want, you can change it. Cubic feet per minute, cubic feet per hour, cubic feet per second, LPM, LPS, anything can be changed here. Okay. Next, outside host stream allowance. If you click here, it will tell this input is used for NFP mandated host stream. So obviously the outside host stream, 100 GPM for light hazard, 250 GPM for ordinary hazard, and 500 GPM for extra hazard. Just now we have seen this. Default pipe material. If you click this, one sheet will come reference number. Like we are taking the reference number 4 for schedule 40, but there are so many numbers given here. Suppose if you are using the CPVC pipe, you can select this 10 number. Whatever the pipe like you are using, you have to just write down that particular number. Even if you are like selecting any carbon steel, so I think for carbon steel, the number is something they have given. Wet steel is different, carbon steel, I think so. Carbon steel is this one. Schedule 10 steel dry. Schedule 10 steel.
Schedule 40. Schedule 40.
Okay. So you need to, otherwise you need to ask to the like vendor that particular technical term for carbon steel. Now sprinkler model, suppose if you know what is the sprinkler model, suppose if you have know the company, which sprinklers you are taking, that you can write. Sprinkler make also you can write. Any like new age company in India, HD Fire, whatever the companies you want to write, you can write down that. Temperature rating, If you don't know what is the temperature rating, just click here. The temperature rating is expressed in degree Fahrenheit by default. The default value of 160 degree has been provided should the temperature be unknown. Though the allowable values range from 0 to 999 unless you have a highly unusual system. A more reasonable range would be 100 to 500 degree Fahrenheit. So you can write any value, but it is suggesting that to go with the 160 degree Fahrenheit. Sprinkler size, we don't need to write the sprinkler size. Fire allows you to enter standard concerning this information only requested so that it can be reprinted with your input report. Labor rate, other labor rates, if you know what is the rate you are giving to the labors for it, installation of sprinkler, it is given in hours, dollar. So we have to write down in dollar. Labor hour, other material costs, these things are not required.
These things are required? No.
Not required. What will you do? Because you are doing the hydraulic calculation. We are not doing the cost budgetary report. That is not required actually. Primary type
Sir,
of
Mr. Atif, for inside hose system allowable GPM 50 or 100 depends on light hazard and the ordinary hazard. Inside hose reel allowable GPM, the second item from
you have to write 100 only. Always you have to write 100 because we have to select two hoses inside the building.
In case of fire.
Yeah. No, always we have to select two hydrant, two hose. So always our inside hose stream allowance will be 100 GPM only. 50 for one. Suppose if you are using 3, you have to write 150 because 50, 50, 50. 100 plus 50, 150. Primary type of discharge. Suppose if you are in your project sprinkler, you have to select sprinkler, and if you are doing only hydrant, you have to select hose. So always we have to select sprinkler because in our projects we will be having sprinkler and hydrant, both the things we are going to be have. Next, hazard description. What type of hazard you are doing? Here you have to select minimum desired density. Just click the light hazard. It will get the density, area of sprinkler operation. Ordinary 1, ordinary 2, everything is mentioned here. Okay. Area of sprinkler operation. Here you have to write down the area of sprinkler operation. See, the area of sprinkler operation is the minimum local area which must be protected by the sprinkler designated as active in the calculation. See, here they have mentioned the minimum. See, minimum area of operation they have mentioned. So the same we have to write. System type is also given, whether you are doing for wet or dry, this also you have to write. Maximum area per protection is also written here. Light hazard 225, ordinary hazard 130, extra hazard 100, high pile storage 100. Okay. After that, this hydrant test data, source of info, hydrant ID. Suppose in your company, if some maintenance work has been done for hydrant, if you have that data, you can write down this data. Otherwise, you can leave this like as it is, you can leave this. Exterior hose flow. Okay, hydrant elevation also, we don't require the hydrant elevation. Just it is used for the printing purpose only, not included in the calculation. Now this test pressure, residual flow, test flow, calculated demand, these values will come after calculation. Enter in PSI the hydrant pressure measure. This data must be entered accurately. This information is used to define the supply curve. Okay. Even this here they will return after calculation have been performed. The program will put the total system demand pressure in this field. So you will get this value and this value after calculation. But these values we don't have to write actually. Test flow rate, test residual pressure, test static pressure. If you are doing the test, you can get from the testing team. What is the pressure we got? What is the test flow rate? So that thing you can write down. Otherwise, you don't have to write anything here. So here only this much we have to fill. Once you have filled this system data, just go to the, see this was the general project data. Next, go to the enter or edit pipe data. In the enter or edit pipe data, now you see, now this particular sheet will come into action. First, what I have to write, beginning and ending node. So this is my beginning node, this is my ending node. Okay. Here
so this is 1020, for example.
1020. Just I will write 1. Okay. 1020. Now this particular will automatically come here. Whatever you will select here, reference number, point number 4 will automatically come here. This one is for the diameter. Here it is written clearly diameter. For example, in our case, the diameter was 1 inch. So,
1 inch.
right, 1 inch here. Okay.
But it is in feet. I do believe it is in feet. Upside.
Yes, feet. You can change also inches. If you want to change in diameter, centimeter, millimeter, you can change it. So here it is written in inches. So I will write inches. Next, it will ask the feet length. Sorry, length is written here 5.5 feet. So I will change to 5.5. Next, K factor. Here it will tell if the node is not a sprinkler, then you should press the I key. Don't press this. Inactive. Don't press this. If the node is a sprinkler and you want to use the default system K factor that you are, see whatever the thing is given here, don't do this because it is a little bit complicated. Simply we will write the 5.65 because if we create this inactive and active means again our calculation will be affected. Here you have to write the sprinkler elevation. Enter the elevation of the node with respect to the zero elevation line. The zero elevation line is usually located at the point demand or supply.
It was 40.6.
40.6, which is usually the CC. So the elevation of the inflow node is typically 0. And the elevation of all the other nodes are given with respect to the inflow nodes. This provision is necessary to provide for pressure loss. So here you have to write 40.6. Now this thing we don't have to write anything because once we do the, once we fill these values, automatically it will calculate. Sprinkler area, this now. Here fitting you have to add. If you click the standard fitting, so here some symbols are given like F for the 45 degree, E for the 90 degree, L for the long turn, T for the T, butterfly wall B, and G for the gate wall, C for the check wall. If I write E here, automatically the equivalent length will added here. 5.5 plus 2, 7.5. Automatically it will come. So you have to complete this particular thing actually.
What is the 7.5 was?
Sorry?
Equivalent 7.5 is the equivalent length of the elbow.
Automatic it will come. So if I select F, 6.5. If I select L, 7.
That's the equivalent length.
Equivalent, yeah. Equivalent length actually. So we don't need to bother and don't click this active or inactive. It is little bit complicated actually. Once you fill this particular thing, okay. Next, what we have to do after filling this, you can also, but it will not come actually because we have not. Okay, because I have not written anything, so it will not open actually. So once again, I will go to this new project and directly you have to go to the calculation. Once you have filled all this thing, go to the calculation. In the calculation, remember I told you like there is a demand mode, there is a supply mode. Clearly it will ask what is the minimum residual pressure at HMD sprinkler node you require. If you don't 7, if you don't know, just click here, it will automatically guide. The minimum should be less than, should not be less than 7. Yeah. If you click supply mode means, if you are clicking supply mode here, what is the confusion means? You will not know what is the residual pressure at inflow, but you have to give here what is the pressure you require. Enter a pressure estimate for each inflow node equal to, like I will write 175 psi here. So my calculation will be limited to 175 psi only. In case if my pressure is going very, very high, so I can limit that pressure with the help of supply mode. And here again, you see the maximum nodal pressure, some imbalance will be there. Initial damping factor, minimum damping factor, just click here. The initial damping factor should be 4 and the minimum damping factor should be 1. It will give. Once you have written this, go to here. We have to write the maximum allowable water velocity. So this value we will be writing 23 feet per second because this is the maximum water we require. And after that, you have to go to solution and just you have to calculate and display. So automatically it will come. Now what I will do, I will just open one file which is done previously. And tomorrow we will solve one different example separately. Okay. I will just open one file which is, I think this file only I will open. The one what I was showing you. See here, this file. Okay, I've just written some name and all this thing. Now here you see here I have written everything here. My pressure range and calculated demand automatically I got. Why means because I have done the calculation. So based on the calculation, it has come here. So we'll be filling this
How
different.
much will
We'll do. This is the pressure. This is the flow. This is the pressure. This is the flow. For this example, I got. I'm just
how
showing.
much 160 Fahrenheit?
Sorry.
160 Fahrenheit, how much would be in 160 Fahrenheit? How much it will be in the degrees Celsius? Around.
Yes, I think I will need to check. Fahrenheit to
25? 25.
71 degree, 71 degree Celsius. It is 71.
What is this pressure? What is this temperature for what? For the bulb? For the bulb? Liquid inside
yes,
the.
this is for the bulb only. But here it is telling that take 160 degree Fahrenheit only. Standard. Okay.
Okay, so.
Just a minute. Now I'm just showing you this. See, this is the most important section. See here, you have to fill very appropriately. So after you write everything, the pressure will come here, the pressure value. Like at each and every node, what is the pressure? It will automatically come here. So this thing we will fill tomorrow for one example, because why means because I wanted to explain you very clearly today, like how to create this sheet. Now, I hope you understood this sheet, how to create this sheet. So tomorrow we will take another example and we'll try to solve this example. Once you write everything, finally what you have to do means you have to just mark this last one. This particular, you have to mark the inflow node. That means you are telling that I need to complete this, like I need to stop here. Okay. 1 minute.
Better to download today the.
Yeah.
Tomorrow we have to
After-
work with you, each one in our PCs.
Yeah.
Our PCs is better.
Obviously. Now in the next section, it will show you what is the K factor, node number, everything it will give you, node elevation, pressure estimation, these things. Calculations, also you have to write some values here. So here I have written 7 PSI, pipe size 23, solution. This is the solution I got. So in this solution, what is given means there are unique pipe sections 19. There are 6 number of sprinklers. What is the maximum velocity? 19. Sprinkler flow, non-sprinkler flow. You can see here, it is telling that the sprinkler number 60 is the demanding sprinkler. See here, this is my sprinkler number 60. This particular sprinkler is the demanding sprinkler. And what is the pressure? Actual residual pressure at 60, 16 PSI. And actual flow is 8.5 PSI. So like this, we will complete tomorrow. We will take another example and we will do this. But I will, in the meanwhile, I will share you this sheet also with the software. Okay. I will share you the link to download the software, and these files and all, I will share it. So you can just go through those files. You will understand. I hope you, at least something you understood about the Allied software. But
yeah.
This,
sir, when we download the software, do we have any crack or something, or it will direct download it? Run
no,
setup?
there will be one license file. One license file will be there. This thing should come actually. One
crack or original
license.
Crack, I believe. Crack, right?
Original we can never get. Don't expect the original, because original files are like
very expensive. Every year you have to renew the license.
Yes. This license file will be there, this black color. So this is the main task actually. So you have to get all this thing and this license file. Let us see. So I will share it today only. I will.
So when we download the file, what should we press first?
I will explain you. Don't worry. Just first, what I will do, I will share this. I think tomorrow only I have to tell you, because this FireW will not come directly. So you have to get it externally, and then you have to, what I will do, I will share this with WeTransfer. So in the
Then, but tomorrow we will download it together, right? Tomorrow.
yeah,
We
tomorrow
cannot
we will
do-
download together. We will download it together tomorrow. That's not
Okay, boss. Thank you.
okay. Okay,
Okay,
then.
thank you, sir.
Okay, thank you.
Okay.
Thank you. Tomorrow, I think next, no, here only, if we change the pressure ranges, the system will change. Like that also I will show you. If you are changing the pressure, it will become miss system. If you are changing the different pressure, it will become the different system. So if you understand one or two example thoroughly, so for any system you can apply this. So next, tomorrow and day after tomorrow, we will try to focus on allied software only next 2 days. Okay.
Thank you, boss.
Thank you.
The
Thank you.
day after, can we eliminate the class?
Yeah, that we will discuss it. So for next 2 days,
Because it's Diwali, sir, and
yes. Because my maximum approach is that in the next 2 days we will complete our allied classes, so that you can at least practice for very like for different projects you can practice. And after this allied calculations, I don't think we will be left out with any major topics. Only small topics will be there. So that's not an issue. So we can see this. Okay, anyhow, we will stop here only. We'll just stop.